4-2, solving systems of equations by substitution. This is the second method of solving systems of equations. Here you have two linear equations, one in slope-intercept, the other one in standard form. In order to use substitution, you want one of the two equations to have a variable by itself. So it could either be x equals or y equals. This one has y equals, so we can go ahead and substitute the 6x plus 7 where the y is in that second equation. So this y is going to disappear and be substituted for what it equals to on the top equation, which is a 6x plus 7. You always want to make sure that you have the exact same variable. If you have two different variables, you substituted incorrectly. So now we just go ahead and solve for x. Distributive property, negative 48x, negative times positive 7, negative 56. Next, we want to check for like terms. We have a negative 3, positive 3, and a negative 48 makes a negative 45x. Solving for x, add 56 to both sides. We get negative 45x equals to 60. Divide by a negative 45. And when you divide, you get a repeating decimal. You're going to need to turn that repeating decimal into a fraction because you cannot round for these. So 60 divided by 45 negative is negative 1.3 repeating, or you can just simplify. 5 goes into 60 12 times, and into 45 9. We can go by 3. 3 goes into 12 4 times, into 9 3. Positive divided by negative would be a negative 4/3. If you're able to solve for a variable, then that means your answer will be written as an ordered pair. So x is our first coordinate. Then you have a choice to now, in order to find y, you can substitute negative 4/3 into either x. I'm going to go with the top one, that will be the easiest. 6 times a negative 4/3, add to 7. I can put 6 as a fraction. I can then simplify. 3 goes into itself once, into 6 twice. 2 times negative 4, negative 8 plus 7 makes it a negative 1. So my solution for this system is a negative 4/3, comma, negative 1. I can always check my work by plugging in x and y into both equations, and they should work. Here's another example. Again, it doesn't matter which variable is by itself as long as one of the two equations has either x equals or y equals. This one has x equals, so I'm going to go ahead and substitute 3y minus 4 where the x is in that bottom equation. So 2 times 3y minus 4 minus 3y equals to a negative 2. Here I have a distributive property. That becomes 6y minus 8. Bring down my minus 3y equals to negative 2. Next, I go ahead and I combine my like terms. 6y minus 3y minus 8 equals a negative 2. Next, solving for y, I'm going to add 8 to both sides. But again, I'm adding 8 to a negative 2, so that makes it a positive 6. And then divide by 3, and y equals 2. We need to be careful that when you are putting this number into an ordered pair, you check to see it is my y coordinate, so that should be my second coordinate. Next, pick which equation you want to plug it back into. Again, I'm going to do the top one because it's x equals, and that's the variable that I need to find. So x equals 3 times the y value, which we just found was 2, minus 4. 3 times 2 is 6, minus 4, x equals 2. So my solution, my one solution for this system would be 2, 2. one more example before you guys can pause and try them on your own. Y equals, again, I can now go ahead and substitute where the y is on the bottom equation. So 2x plus 3 times negative 9x plus 6 equals a negative 7. Be careful when you distribute, watch your signs. A negative 27x, 3 times 6, positive 18 equals a negative 7. Combining your like terms, 2 minus 27 is a negative 25x, plus 18 equals a negative 7. Solving for the variable, subtract 18 to both sides, but same sign, add the two numbers together and keep that sign, so it becomes a negative 25. Divide by a negative 25. Negative divided by negative is positive, and a number divided by itself is always a 1. So right now my answer would be 1 comma a number, because 1 is my x value. Again, choosing whichever equation you want. I'm going to go ahead and do the first. Y equals negative 9 times a positive 1 is a negative 9 added to 6, and y equals a negative 3. So my answer should be here, 1 comma negative 3. Next, you can pause and try these problems on your own. These are the two try-its. You can pause here, try them on your own, see if you get the same answers. X equals, so I can substitute where it says x on the bottom equation. There is no distributive property here because there is no number, there's no coefficient in front of the x. So I can just go ahead and take away this x and substitute it for y plus 6. It gets replaced. And then plus y equals 10. Combine your like terms. You have 2 y's plus 6 equals 10. Solving for y now. Subtract 6 to both sides. 2y equals 4. Divide by 2. And y equals 2, which is the second coordinate. Now to find my x, again, you can substitute it for either equation to find the x value. I'm going to use the first one. X equals y, which is 2, plus 6. X equals 8. So my solution for letter A would be 8 comma 2. Letter B, y equals, so it's going to be substituted where the y is on the bottom equation. This one does have distributive property. So 2x plus 3 times 2x minus 1 equals a negative 7. Distributive property here. 6x minus 3 equals a negative 7. Combining your like terms, 8x minus 3 equals a negative 7. Add 3 to both sides. Get a negative 4. Divide by 8. Be careful, you are dividing by 8. You're dividing a bigger number going into a smaller number. That is a negative 1/2. Because this number, this fraction does terminate, if you want to go ahead and use negative 0.5, you can. But I'm just going to go ahead and keep it as a fraction, negative 1/2, and I'm now going to substitute it for, on the top equation, I'm trying to find y equals 2 times a negative 1/2 minus 1. Positive times negative is negative, half of 2 is 1, minus 1, same sign, add the two numbers and keep the sign. So my solution would be negative 1/2, comma, negative 2. If you were to have graphed any one of these, they would have intersected at 2, 2. This would have intersected at 1, negative 3. This would have intersected at 8, 2, and negative 1/2, negative 2. So these are all one solutions. Next, we have some that are not going to be able to be solved, but you're going to solve them the exact same way. Y equals, so I can go ahead and substitute this where the y is on the bottom. So 6x minus 2 times 3x plus 1. You need to be extremely careful with your signs when you distribute. Negative times positive, negative 6x, negative times positive, negative 2. 6x minus 6x. When I go ahead and combine my like terms, they are opposite. So they are going to completely cancel out and then bring down what you have left remaining. Negative 2 equals a negative 2. So since this statement is true, it's an identity, then your answer is infinitely many solutions. IMS would be your answer to me. If you were to graph this, this would have one line only, because if I would turn the bottom equation into slope-intercept, it would be y equals 3x plus 1. This one you have to be extremely careful to. The bottom equation is the one that has the y equals. So this is 5x minus 4 is where I'm going to substitute for y on the top. But because it has a minus sign in front of it, I am going to put a 1 here because that minus sign is going to belong to that entire expression. So I am going to distribute by a negative 1. So negative times positive, negative 5x, negative times another negative is a positive 4. Again, you need to be extremely careful with your negative signs. Positive 5x times a negative 5x cancels out. Does a 4 equal to a negative 4? No, it is not a true statement. It is false. So because this is a false statement, your solution has no solution and has to be your answer to this problem. Pause and try these two on your own. The bottom one is what you are substituting for the x on the top. So 4 times negative 2y plus 1 plus 8y equals a negative 8. Distribute watch your signs. Negative 8y plus 4 plus 8y equals a negative 8. Combining your like terms are opposite, so they completely cancel out. 4 does not equal a negative 8, so this would be no solution. The bottom one is what I am substituting for the y, so 2x plus 5 times a negative 2 over 5x minus 1 equals a negative 5. Bring down 2x, positive times negative is negative. The 5's cancel out, so it becomes a negative 2x. 5 times a negative 1, a negative 5. 2x minus 2x cancel out. Negative 5 equals a negative 5. That is a true statement. So my answer here will be infinitely many solutions. Oh, those are examples. You can pause and try these on your own. 1 equals negative 5, substituting for y is on the top. So x negative is continue here, minus, I don't have to put the plus sign. This disappears and gets substituted. Negative x plus 5 equals to a negative 4. This cancel out. 5 does not equal to negative 4, so this would be no solution. The bottom one, y equals, this will be substituted for the y on the bottom. Again, don't need to put plus minus, just minus 2x, negative 2x cancel out. So 5 equals to 5, true statement. So infinitely many solutions. So in your solving systems, you can either have one solution, you get an order pair, either no solution or IMS. per ride. River's Edge, total cost equals to $18.50 admission plus 50 cents per ride. When do the dollar amounts equal the same for the number of rides? Well, one is 12.50 plus 0.75x equal to 18.50. You're substituting. You're taking away the y's. And then cancel out my smaller x. Subtract 50 cents from 75 cents. That would be a quarter. 0.25x equals to 18.50. Subtract 12.50 for both sides. And we get $6. And then $6 divided by 0.25 would be 25 cents would be 24 rides. So 24 rides would cost the same at both parts. So this is an overview. If both equations are written in standard form, then we have to rearrange one of the two equations. It doesn't matter which one. Go for the easiest one, and it doesn't matter which variable you decide to get for yourself. Here they got x by itself by subtracting the y to both sides. Once they got a variable b by itself, went ahead